Hello, good morning. My name is Omon Edeki, and we're going to go over a cybersecurity use case. So the PCI Data Security Standard is a standard that's used to help organizations govern and secure their physical and digital and network assets with respect to payments systems. So the PCI Council has come out with a framework called PCI DSS 4 that spells out a framework for how to do PCI DSS risk assessments, how to identify components, and how to ensure that each of these components meet a minimum threshold of PCI security. This is a discipline that's used not only for cybersecurity, but it's also used for availability, systems performance, uptime to ensure that services and value is delivered to the customers at a very high percentage. So in this example, what we did was we set up an SOP for the PCI DSS onboard new component risk assessment. So this SOP workflow will be run when a new system or a new subcomponent of a system gets added to the PCI DSS network. Or it could be a new platform or a new component. All these steps that the owner of the asset will have to go through to ensure compliance to the PCI DSS in this area. Okay, so the first step is to identify the DNS hostname, if there's going to be one issued, the cloud network, the allowed list configuration. This is for firewall security to identify what are the other external systems that this component can connect to. Anything that's in the allow list, you're granted access to connect. Anything that's not on the allow list by default will be blocked. Identify if the system or the component has privileged accounts, and are they properly vaulted in the PAM system. Very important. Privileged accounts control access to these systems as admins, so you want to be able to control the passwords and ensure that only the right people can see those credentials. Does the system support automated access provisioning and deprovisioning? And then SSL certificates. Many systems usually will have an access layer that uses SSL certificates to encrypt the communications to that system, or they might have certificates within the actual component that govern access accordingly. And then last but not the least is every system needs to have what we call the site reliability engineering SOP that a system admin or performance admin will run in a frequent basis to ensure the health of that particular component. Thinking of things like, do we still have access to the system? Are we checking disk space? Are we testing the latency? Are there any licenses associated with this particular resource? Is it on a cloud account? Are the bills paid to ensure there's no interruption of access? That's what this is. Do we have that SOP defined for the system? Usually you would already have had an SOP for other similar systems, so this just ensures that you have one that's identified. So that's what's going to take to onboard a new system to the PCI DSS. So this could become a standard for how you onboard your new components into the network. So let's say we have a particular new asset, an AWS server, and we want to run the SOP. So this is the owner of the system. They just have to attest that they have been through this SOP to ensure that this particular system meets the criteria required to be a part of the system, to meet the PCI requirement. So you click on Start Certification, right? And basically all it takes is that you just have to go through the checklist. Does it have a host name? You just specify the does it have the host name? It could be DA dot PCI dot cloud, right? So you specify the host, and then you just identify. So VerityBeyond in this context is basically a data collection system that ensures that you meet the minimum requirements. Okay, and you have this information and this is your control to the organization that you've met the criteria. And this could be something that's run maybe on an annual basis, right? I don't see a need to run it more than once a year, right? And then that ensures that you have availability and you meet the minimum level of quality. The subnetwork, typically this is when you onboard the system. You identify a network, so I'll just say default. The allowed list, so what this is going to be is a list of all the network systems that you can go out and into in terms of connectivity. And here, what you can do is that you can just attach, if you have information, let's say you have detailed information and you want to add it to the workflow so that it's logged, you can attach it. Typically you would just pass this. You can enter in the allowed list here, or you can go ahead and explicitly add. So you go to attach workflow, and then you can attach all the list of outbound systems, etc. And that way you have that detail. It's all going to be attached to the same SOP. So you come back here, you come back to the next list. Does it have privileged accounts and are they vaulted? Using maybe a tool like CyberArk or Delinea or some kind of PAM solution. And then do you have automated access provisioning and deprovisioning? Using tools like SailPoint to automate the onboarding, the joiner, the mover, the leaver workflow. So all of these drive the framework. And let's say you don't quite meet the criteria, you can just say, you know what, this is still in progress. Maybe we can't work in it this year, right? Maybe, budget and time does not allow, or maybe we work in a joiner, but we haven't quite done the lever for the app. You can log it in the system, right? We all know that time and budget is tight, but GRC talks about how you use frameworks to drive priorities. So you log it. This year you can't meet the criteria, but you know what? Next year when you're doing this, you know where you left off last year, you can pick it up, right? And then the app owners will go through this process. Then you can have the managers who are doing the certifications, they can see this particular report, and then they can make a case about, all right, this is where we're at from a risk standpoint. The following year, how do we mitigate and close the loop on that particular risk item? Okay, and then the next step here, we'll be talking more about the SSL certificates. So do you have those identified? Do you have a policy in place? So again, this is really a way to ensure that the team is on the same page with the minimum standards for this particular asset class type. Do you know when the SSL certificates are generated? Do you have a process for renewing them, etc., etc.? And then last but not the least is, do we have a site reliability engineering review for this particular asset? And is it defined, is it approved, and is it assigned to the right parties? Do we have a process in place to maintain the site reliability engineering? Once the system is up, it's in production, do we have an SOP for the critical users, for the critical admins to follow to ensure that the system is up? Typically it's run on a weekly basis, sometimes daily, right? That way the knowledge about how to maintain that system, how to verify that it's actually up, it's shared across a team of people. So this is not just a tool for ensuring uptime, availability, and security, but it's also a tool for ensuring that the knowledge is diffused across the organization. So there you have it. So this is what the risk assessor or the site reliability engineering admin will run on a periodic basis, and then they log it, and then they're done. So you can set up the SOPs. All this content can be changed, it can be defined, but this is just an example for how to set up a PCI DSS. You can do the same thing for other workflows like HIPAA and other frameworks to ensure that your users are following the SOP that you've established to meet that minimum level of quality. So that's it for this demo. Thank you so much for your time. I really enjoyed this. I encourage you to reach out and let's see how we can use GRE SaaS solutions to improve your business workflows for your industry, for whatever use case that you're targeting. Thank you for your time and have a good day.